So now that we know what exponential functions are supposed to look like, we're going to actually go about graphing a function. So our first step is to make a table. So on number 1 here, we're going to go through these steps. We're going to make ourselves a table. And we're going to choose 5 values. So these 5 values are very specific. We're going to choose 2 that are less than 0, the number 0, and 2 that are greater than 0. So basically that means 2 negatives, 2 positives, and 0. So in our case, -2, -1, 0, 1, and 2. And we're going to plug these in for 0. So on our -2, we would have 2 to the -2nd power, 2 to the -1st, 2 to the 0, 2 to the 1st, and 2 to the 2nd. So let's start here with 2 to the 2nd power. That is simply a 4. 2 to the 1st power is 2. And if you recall our properties, 2 to the 0 power is going to be 1. 2 to the -1st, remember that a negative exponent means a reciprocal, so this would be simply 1/2. And 2 to the -2nd would be 1/4. So now that we have our x and y values, we're going to plot these points on a coordinate plane. So we're going to do -2, 1/4, which is really, really close to the x-axis. -1, 1/2. 0, 1, 1, 2, and 2, 4. So step 3 says to draw a smooth curve through the points, but then it tells us to be careful and not let our graph cross the asymptote. So if you'll recall, there is an invisible line that is called the asymptote. So in this case, our invisible line is going to actually be on the x-axis. And remember, we use a dotted line to show that it is not really there, but that our graph is never going to cross it. And the reason there is an asymptote is because as our x values get bigger, our graph is going to continue getting bigger. It's going to shoot up really, really high. Likewise, as our x values get smaller, they go more and more negative, we're going to just keep getting smaller and smaller fractions. So if I do -3, I'm going to have 1/8, and then 1/16, 1/32, 1/64. Those are going to get really, really small, but they're never going to be 0. So what's going to happen is this graph is going to just get really, really close, and then it's going to almost look like it's leveling out, and that's simply because we can't see those small numbers. Now, one thing I want you to be careful of is not to make your graph go up like that. That is not an exponential function. Okay, so that piece is not correct. It's going to look like it's really close to the x-axis, but it cannot cross this line. So again, you got to make sure it's not doing something like this and crossing over the line. It needs to stay above the line, the asymptote, and it needs to be kind of leveled out, so not curving back up. Now, our domain for this function would be all real numbers. So x is a member of the reals. And the reason it's all real numbers is because you really can pick any number in the world for x. We picked 2 negatives, 2 positives, and 0, but we could have picked fractions or decimals. These were just the easiest values to choose. Our range, on the other hand, is still all real numbers, but it's not every real number. It's going to be all real numbers above 0. And it cannot equal 0 because this graph is never going to be on the x-axis, which is where x equals 0 and y equals 0. So y is greater than 0 because all our values are going to be positive, and they will always be positive. So what I want you to do is I want you to try number 2. So go ahead and pause the video, and when you're ready, turn it back on. All right, so on number 2, you should have gotten your values to be 1/9, 1/3, 1, 3, and 9 for your y. And you would have seen this same growth pattern. It would have started out really slow and then shot up, and it actually shoots up a little bit quicker than my base of 2, and that's because a base of 3 multiplies is a bigger number. So as your base gets bigger, so will your graph. It's going to go up a lot quicker. And both of these are growth functions simply because the base is a number bigger than 1. So if you have a base 2, 3, 4, 5, and so on, it's going to grow from left to right. Okay, so hopefully you got your domain as all real numbers, and then your range is all real numbers greater than 0. They have the same domain and range here, and make sure you have your asymptotes lightly drawn in. It's not a solid line, it's a dotted line. So if you got this one correct, if you'll give yourself a little smiley face so I know you got it right. If you got it incorrect, if you'll give yourself a little frowny face so we know that we need to look at this tomorrow. So let's look at number 3. So we have y equals 1/2 to the x power. So it's the same steps. We're going to start by drawing a table. We're going to use our same 5 values, -2, -1, 0, 1, and 2. And this time when we're plugging these in, we're going to make sure and we're going to put our fraction in parentheses. Okay, so 1/2 to the -2nd power, remember this negative just means it's the reciprocal, would equal +4. 1/2 to the -1st is 2. 1/2 to 0 is 1. 1/2 to the 1st power is 1/2. Oops. And 1/2 to the 2nd power is going to be 1/4. So when we draw this time, we're going to do -2, 4. We're going to have -1, 2, 0, 1. Okay. And again, we have our asymptote because this graph is never going to touch the x-axis. It's never going to equal 0. So when we draw on our smooth curve, it's going to go flat over here to the going towards the right, and it's going to jump up going to the left. Okay, so this is opposite of what we saw in numbers 1 and 2 because this is a decay function because 1/2 is between 0 and 1. So anytime the base ends up being a fraction that is between 0 and 1, you're going to find that it falls from left to right. And when it's a number bigger, it's going to grow from left to right. So our domain here, I'm going to squeeze this in up here. Our domain is again all real numbers. And our range is still the same. It's all real numbers such that y is greater than 0. Because our graph again is above the x-axis. So go ahead and try number 4. Pause the video. When you're ready, turn it back on. Okay, so again, your values are 9, 3, 1, 1/3, and 1/9 for your y. Your domain is all real numbers, and your range is all real numbers greater than or equal, just greater than 0, not equal. Make sure you don't have an equal to. You should have your asymptote drawn in. Make sure there are arrows on each end of your graph. It should be flattening to the right and going up pretty quickly to the left. So if you got this one correct, give yourself a smiley face again. If you got it incorrect, please give yourself a frowny face so I know that we need to talk about this one tomorrow. And remember, you can be writing down questions as you go.